Welcome to qnawire.
This problem gives us the following equation: CO gas plus 2H2 gas forms methanol, CH3OH gas. And the first thing we want to do is find the limiting reactant. So for this, we can do the ideal gas law for carbon monoxide and hydrogen gas separately to get the number of moles of each. And once we have the number of moles of each, we can compare them to see which one is limiting in this case. So I'll start with CO. And so for CO, again, we have the ideal gas law, PV equals nRT. And we want to solve for N. And so our P in this case is 232 millimeters of mercury, which we can divide by 760 to convert to atmospheres, and that's 0.30526 atmospheres. Our volume is 1.50 liters. N is our unknown. R is 0.082057 liter atmospheres per mole Kelvin. And our temperature is 305 Kelvin. And so we can rearrange this equation to solve for N. N equals PV over RT. And when we do this and we plug in these numbers, we get our number of moles to be 0.0183 moles of CO. And so now we want to do the same thing for hydrogen gas, H2. And so our pressure in this case is, and this is for H2, our pressure in this case is 397 millimeters of mercury, which again we can divide by 760 to convert to atmospheres, and that's 0.52237 atmospheres. Our volume is again 1.50 liters. Our R value is again 0.082057 liter atmospheres per mole Kelvin. Our N is what we're looking for, and our T is 305 Kelvin. So when we take that same rearranged ideal gas law, N equals PV over RT, and solve with our numbers here for H2, we get that there's 0.0313 moles of H2. However, since there are 2 moles of H2 for every 1 mole of CO, we want to divide this by 2 when comparing to find the limiting reactant. And when we divide this number of moles by 2, we get that there are less than there are for CO, which means that H2 is our limiting reactant. So our limiting reactant is H2. So now we want to find the theoretical yield of methanol, given that H2 is our limiting reactant. And so the first thing we do is take our moles of H2, 0.0313 moles of H2, and convert it to moles of methanol. And so based on the given chemical equation, there's 2 moles of H2 for 1 mole of methanol, CH3OH. And we can then take the molar mass of methanol, 32.04 grams per mole, to convert this into grams. And when we do this, we get that the theoretical yield is 0.5016 grams of methanol. And that is our final answer.